Welcome to Coding Kids. Today I'm going to show you how to build this game, Metal Detector Hunt. First, let's look at how we play it. The player hovers the metal detector by moving the mouse pointer around the screen to find the hidden objects: a key, a bell, some glasses, and a guitar. The metal detector will buzz when you are near an object. The closer to an object, the higher the pitch of the buzzer. When you think you're over an object, press the space key to dig. The metal detector displays a message that says digging, and if you click on the wrong place, it says nothing here. Otherwise, you find the object which goes into the bowl. Now, let's build the game. There are 6 parts to the game. 1. Game backdrop. 2. Metal detector. 3. Bowl. 4. Hidden objects. 5. Detecting hidden objects. And 6. Digging up hidden objects. I will build this game one step at a time. First, let's start with a brand new project by clicking on the Create button on the home page. In a new project, the cat sprite is always set as the default sprite. A sprite is a character or object that we use in making the computer program. Let's delete the cat sprite. For step 1, let's add the backdrop by clicking on the miniature backdrop icon on the bottom left of the screen. Then, scroll through the backdrop library until you find a backdrop that you like. You may choose a different backdrop to me. Double-click on the backdrop you have selected, or click on the backdrop, then click the OK button. For step 2, let's select a sprite to use as the metal detector. I will select a new sprite from the Sprite library. I'll select the Button 1 sprite. You can resize this sprite and make it smaller. You can click the shrink icon in the toolbar at the top and then click on the sprite as many times as you desire. For step 3, we need to add a bowl sprite. This will be used to put our discovered objects in when we find them. To do so, select a bowl sprite from the Sprite library and put it on the top right corner of the screen. In its Script tab, select when green flag is pressed. We want the bowl to go to this position at the start of the game. Under Motion, we select the Go To block and change the coordinates to X is 200 and Y is 150. We want to place the bowl sprite behind any other sprite that goes near it. We do this by selecting the Go Back 1 Layers block under the Looks category and then change its number to 99. If you want to make sure a sprite is always in the back, 99 layers is usually enough to push it to the back. If not, add another 9. Then connect these 2 blocks together. For step 4, I will program the hidden objects. I want to use 4 different objects: a key, a bell, glasses, and a guitar. However, instead of using 4 sprites, I will create 1 sprite with 4 costumes. First, I will select a key from the Sprite library. To this key sprite, I will add 3 more costumes: a bell, glasses, and a guitar. So now I will go to the Costume tab and press Choose Costume. Next, we need to select 3 different costumes for our key. I will select a bell as the second costume, glasses as the third costume, and a guitar as the 4th costume. Now to program these 4 different objects, go to the Scripts tab. First, we need to select the When Green Flag Clicked block and connect it to a block that says Switch Costume To under Looks category. We want to switch the costume to the Key sprite, so select Key Sprite from the drop-down menu. This makes sure that when the game starts, the key is the first hidden object that we find. Next, we need to add a block that says Hide, which is found under the Looks category. Connect this block underneath the Switch Costume To block. Then we need to connect a Go To block so that we can decide where our hidden object sprite is located on the screen. The Go To X, Y block is found under the Motion category. Now, instead of inputting specific coordinates, we want to randomly generate where the hidden object appears. We want the hidden object to appear randomly anywhere on the stage. To do this, we need to use the Pick Random 1 to 10 block, which can be found under Operators. Place the Pick Random block inside the x-coordinate space and repeat for the y-coordinate. For the x-coordinates, change its range from -220 to +220, and for y-coordinate, change its range from -160 to +100. This will make our sprite appear randomly on our screen. However, because the upper y limit is +100, it cannot appear in the bowl. For step 5, we need to program what happens when the hidden object is found by the metal detector. The hidden object should appear and glide to the bowl, hide again, switch costumes to a new hidden object, and relocate to a random point on the screen. To do this, we need to use a broadcast message, which could be found under the Events header. First, I will select the When I Receive block, which is an event block. Click on the down arrow and select New Message. We want to name this new message Found. Now, place a Show block underneath the When I Receive block. This makes sure that when we find the sprite, it appears on the screen. After that, connect a block that says Glide to X, Y. This can be found under the Motion header. Change X to 200 and Y to 150, the coordinates of the bowl, so that the sprite will glide to the bowl. So now our sprite will appear when it receives the message Found and then glide to the bowl. Let's click on our code block to test it. It works! However, I want it to glide more slowly. We can do this by increasing the gliding time to 2 seconds. Once we get to the bowl, we want our sprite to hide again and switch to its next costume. We can do this by adding a Hide block followed by a Next Costume block, which can be found under the Looks category. Now our hidden object has disappeared and has a new costume. The final step in coding for the hidden object is to make it randomly locate on the screen again. We can do this just like we did before by using a Go to X, Y block and 2 Pick Random 1 to 10 blocks. The range of X and Y should be the same as what we used before. Let's test our code by clicking our code block. It works! Let's click it again to see if it changed costume and moved somewhere else. Success! Next, we want to program button 1 to hover around the screen, following the mouse pointer. Click on button 1 and then click on the Scripts tab. To make the button follow your mouse pointer, you need 3 blocks. When green flag pressed, a Forever block, and a block that says Go to Mouse Pointer. Let's drag these blocks into the workspace. Place the block that says Go to Mouse Pointer into the Forever loop, and then connect them to the block that says When green flag pressed. Now the button 1 sprite will follow the mouse pointer around the screen. Next, we need to code for the sound effects. For these sound effects, we want to use different notes on a single instrument. We can do this by choosing a block that says Set the instrument to in the sound category and changing its number to 10. This is a clarinet. There are many musical instruments that are available for use, each with its own number. You may choose a different instrument to me. In the sound category, there is another block that says Play note 60 for 0.5 beats. This block will play the note number 60 for 0.5 beats. With this block, various notes between 72 and 48 can be played. My aim is to produce notes when the distance of metal detector from the hidden object is less than 100 pixels and the space button has not been pressed. The closer to the hidden object, the higher the sound. Next, we need to code for the space key being pressed. First, we need a When green flag clicked block found under the Events category. To do this, we will use a variable that shows if the space key is being pressed or not. This variable will be called Detector On. In the Data category, make a variable and name it Detector On. Untick the variable so that it doesn't show on screen. Now we need to place a set detector block and set it to 1. After that, place set instrument to 10 below it. To make sure that this sprite is not hidden behind the background, use a go to front block found under the looks category. Next, we need to go back and add some code so that the metal detector can sense when it is near the hidden object. Let's add a forever loop below go to front, and inside we'll place an if-then block found under control. In its condition, I will use the AND operator to check two conditions simultaneously. The first condition is when our variable detector on equals to 1. You can make this condition with an equal to block under the operators category and put the variable name on one side and the number 1 on the other side. This condition means that our detector must be on for anything to happen. The second condition is whether the distance to the key is less than 100. Make this condition with the less than operator and a block named distance to, which is found under the sensing category. This condition allows the metal detector to tell if it is within 100 pixels of the hidden object. If these two conditions are true, various notes from 72 to 48 can be heard based on the distance of the metal detector from the hidden object. Now we need to use some maths to make sure that the pitch goes higher as we get closer to the hidden object. We can find our mathematical operators in the operators category. Our highest note is 72, which we'll be taking away from as we increase distance. We need a subtraction operator block for this. On the left, we'll place 72. Now we want to take away a number based on how far away we are from the hidden object. Let's grab a division operator block. We'll add the distance to key block from sensing to the left, then divide it by 100. We now need a range of notes to play based on distance. Let's grab another subtraction block. 72 is our highest and 48 is our lowest. To get our range, we subtract these two numbers. Now we want to multiply that by the range of notes we want to use. Using the multiplication operator block, we can multiply our distance by our range. Now let's place this operation on the right-hand side of our original subtraction block. Place the connected blocks in the play note block found under the sound category and change its beats to 0.1. This will make it play faster. Next, let's program the sound when the space key is pressed. When the space key is pressed, the shaker sound should be played. Let's use a block named when space key pressed and connect it to the block that says play sound until done, which is under the sounds category. To choose the shaker sound, click on the sounds tab and select choose sound from library under new sound. The shaker sound can be found under the percussion category. Click back on scripts, then click on the black arrow on the play sound until done code and select shaker. For step 6, we need to code for what happens when the space key is pressed. Select two blocks when space key pressed under events and set detector onto 0 under data and connect them. Then add a block that says think for 2 seconds under looks and write digging in the dialog box. So now when the space key is pressed, a message appears and says digging. After that, use the if-else block to check whether the distance to the key is less than 10 or not. Make this condition using a less block found under operators and the distance to mouse pointer found under sensing and change distance to key. Put distance to key in one side of the operator and on the other side write 10. Place this block inside the if part of the loop. Next, we need to make a new variable and name it items found under data. If the conditions from before are true, the game will broadcast found and will change item found by 1. So we need to add the message broadcast found underneath distance to key is less than 5. Then we need to add change item found by 1, which can be found under the data header. If the condition is false, the block in the else part of the loop will operate. Put in the else section a block that says think for 2 seconds and change its message to nothing here. Outside of the if-else block, put a wait block for 1 second and add set detector on to 1. This makes sure that our metal detector will turn back on afterwards. Under when green flag clicked, add a block to set the item found to 0. This makes sure that our game will reset properly. Now, let's click on the green flag to test our game. Great, it works! Add your own features to personalize the game. Perhaps add a timer to play the game with a limited time, and change the backdrop when you find all the hidden objects within the time limit.